Okay, sir. Yes, sir.
Yeah. Good evening, everyone. Welcome to fourth day. As a part of today's session, we are going to discuss about t-test. I hope I'm audible to all of you and my screen is visible as well. Am I right? Shall we go ahead? Yes, thank you.
Sir.
Yes, sir. Yes, sir.
Thank you. Yes, thank you so much. Thank you. Now, as a part of today's session, I'll be talking about one sample t-test, independent sample t-test, and paid sample t-test. Time permits, we'll discuss a few more concepts. And I want everyone should practice it simultaneously along with me if you're ready to do it. Okay. Now coming to the one sample t-test. Before that, I just want to have a brief discussion about parametric and non-parametric. Though I have discussed about it on the day one as a part of understanding basic terminologies, there are two types of statistics: descriptive statistics, inferential statistics. The main objective of inferential statistics is to give some kind of conclusion to generalize the major findings of your study. Now, as a part of inferential statistics, again, we have two types of statistics: parametric, non-parametric. Now, what are the parametric tests we have it? In order to carry this particular parametric statistics, one has to fulfill certain assumptions. Now, if you're going with a comparative based test, t-test, we have certain assumptions. If you want to conduct a correlation test has its own assumptions. Means one has to fulfill that particular assumptions, like eligibility criteria. Okay? Whether I can able to conduct correlation test for this particular data. So they have certain eligibility criteria. So as a researcher, one has to fulfill certain assumptions. If you can able to fulfill that particular assumptions, one can go with parametric test. In case if you're not able to fulfill the assumptions, one has to go with alternative statistics. They're nothing but non-parametric statistics. For every parametric statistics, we have some non-parametric statistics we have it. We are also going to discuss about parametric as well as non-parametric statistics as a part of this particular workshop. But today I'll be covering t-test. Now, what are the parametrics that I will talk about step by step with along with the test that you're going to conduct it. Okay. Overall, we have discussed on the day one, but right now, from today onwards, for each test, what are the data requirements we have it? What are the assumptions one have to fulfill it? Okay. Now, coming to the one sample t-test. As you can see on this particular slide, one sample t-test is a parametric test. Okay. Now, it is also known as single sample t-test. It is also known as a dependent sample t-test. One sample, as the name itself indicates, you are going to have one variable, one sample data that you're going to have it. The main objective of conducting this particular one sample t-test is to compare the sample mean with the population mean. To compare the sample mean with the population means. Means there are two things are here. I'm saying that we are going to compare the sample. The sample is nothing but the data that you're going to collect as a part of your research. And you're going to compare with the population mean. Now, somebody can ask, what is population mean? Now, when it comes to the population mean, for example, if you're referring to elderly population, you were saying that life expectancy rate is right now around 71%. 71 years of life expectancy rate. When India got independence, our life expectancy rate was around 35, roughly around 35. Now one can able to see around 65 to 71, our life expectancy rate is increased. Now, as for the overall from the Indian context, we have don't go by face value. Just I'm saying roughly around 71 life expectancy rate right now from the Indian context. Now, for example, we have Professor Divya. She want to conduct research and she want to understand overall an average population. Overall population life expectancy rate is 71 years. But what about the Gujarat state? In Gujarat state, what is an average life expectancy rate? So she started collecting data from around 5,000 people and 500 families. And she started understanding in the 500 families, on average, what was the life expectancy rate? Now, the 5,000 is the sample. And the overall, I mentioned about 71% is from the all over Indian context. So as a part of population census, as a part of whatever we have NSSO data, we have 71 is the national level average expectancy rate, that is population mean. Now I'm comparing sample mean. The sample is nothing but the data that I collected. I'm just comparing sample mean with the population mean. Let me put it another way. Imagine that you are working in a rice mill factory. Don't take it other way, just as a example. Imagine that you're working in a rice mill factory and you have 50 kgs bag, 100 kgs bag, 200 kgs bag, rice bag. Okay. Now one of the wholesaler is coming and he want to buy at a time around 50 bags. One of the wholesaler is coming and he wanted to sell it for retail in his region, in his area. So you want to buy bulk so that he can get that cheaper rate. Now you are telling to that person, this is 50 kgs bag, this is 100 kgs, that is 200 kgs bag. Now you can't simply blindly follow whatever you are saying it, right? So they want to take sample, they want to check it. Okay, you are saying there is a 50 kgs bag, just let me verify it. So in order to verify it, he will take around 10 bags and you will see whether it's really 50 kgs or not. So he'll take small sample to verify whether it's really 50 kgs. Is it really 50 kgs or 19 kgs? Sorry, 49 kgs or 44 kgs. Now, I hope you are able to understand what I means to say. As a owner of this particular rice mill factory, I'm saying this is 50 kgs bag. But the wholesaler, he wanted to take small sample before giving more advance money, as he's going to buy in bulk. He want to check it out. So 50 kgs is a sample. It is a population mean that you're telling to the wholesaler. And he is going to take around 10 bags, that is sample, and he really check it out whether it's really whatever the rice mill factory owner is saying is really 50 kgs or not. Means you're going to compare the population mean with the sample mean with the population mean. Now, the point here is that in every case, you may not able to get the population mean. Every case, you may not able to get the population mean. Now, here what happens is population mean can be based on certain statistics published by recognized institutions, maybe previously published research articles. It can be hypothetical value, right? So there are certain parameters one can use to determine what is population mean. So based on the population mean, you are going to calculate your sample mean and you are going to compare it. So basically, as a part of the one sample t-test, that is dependent sample t-test, examines whether the mean of a population is statistically different from the mean, means the sample mean of a population is statistically different from known or hypothesis value or not, right? So the test variable is only one variable. In order to conduct one sample t-test, we required certain data requirements. Test variable that is continuous. One has to have quantitative data if you want to go with one sample t-test. And second one, scores on the test variable are independent. For example, I'm collecting data from 20 people. Respondent number one data has to be given to respondent number one. I can't give respondent number one data in two places, 1 and 5. So the scores, whatever I'm getting, there has to be independent. Okay. Random sample of data from the population. You must have collected data by using random sample. So that is one of the important requirement for conducting any parametric statistics. Another most common and very important data requirement or assumption is that normal distribution of the data. As a researcher, you are assuming that your data is distributed normally. And you are also going to test it. As your assumption is, for example, you are assuming that your data is distributed normally. If you are able to ensure that your data is distributed normally, you will go ahead with the conducting parametric test. In case, if you're not able to fulfill this particular assumption, you'll go with non-parametric test. So second one, lastly, no outliers. There should not be any outliers in the data set. So these are the basic requirement for conducting one sample t-test. Okay. Now, coming to the hypothesis. This is the problem of the statement. Like, on average in Gujarat, population mean height is 66.5. As per the Government of India report, it's roughly, okay, and don't take it seriously. Height of the Gujarati people is 66.5. inches, 66.5 inches. Now, as I'm coming from Gujarat, I'm working in Gujarat. I want to collect the data from the Gujarat state itself. So I decided that I'm going to collect the data from 2000 people, just to see whether, as Government of India mentioned, that on average people in Gujarat are 66.5 inches. I just want to compare it. So in order to compare this particular data, I'm collecting data from 2000 people in Gujarat. The 2000 is a sample mean. So here my null hypothesis is that the sample mean height is equal to 66.5. So the 66.5 is the population mean, okay? Whereas the sample mean is the data that I'm going to collect as a part of my research work. Now, when it comes to the alternative hypothesis, the sample mean height is not equal to 66.5. The sample mean height is not equal to 66.5. Now, coming to the data requirements or the assumptions, I need to fulfill 5 criteria. Test variable that is continuous. So we need to have the variable in order to conduct one sample t-test that must be continuous data. Okay, so one has to see that what are the variable that is going to use that going to be continuous data. Scores on the test variable are independent. That is assumed as a researcher, you know how you have entered the data, right? There should not be any kind of mistakes. Random population that also cannot be tested, because as a researcher, you are saying that I collected data by using random sample. Now, one can only test normal, whether data is distributed normally or not. Now, in order to understand whether my data is distributed normally or not, as I mentioned in even yesterday's session, there are so many options are available. But as a researcher, one can use one or two tests as a part of your research. Even one is good enough. Like we have descriptive statistics, we have Sperry-Wilkie test, we have box plot, we also have histogram, and we also have QQ plots. So there are a number of options are available. If you go to SPSS, one can also see steam and leaf. So there are more options are available, but any one statistics is good enough to report as a part of your research saying that my data is distributed normally or not. Okay. Now, how to conduct the normality test? As we are going to rely on Sperry-Wilkie test for the entire workshop, at least from my side, I'm going to prefer always Sperry-Wilkie test as a statistical test to understand whether my data is distributed normally or not. Now, when it comes to the normality distribution of the data, my null hypothesis is that the sample is drawn from a normally distributed population. As a researcher, I'm framing my null hypothesis for testing the normal distribution of the data. The sample is drawn from a normally distributed population. Whereas when it comes to my alternative hypothesis, the sample is drawn from a normally not distributed population. Okay. Now, next point here is that we are going to compare the p-value to some predefined threshold. So we have some threshold value. What are the test value that you are going to get it? We are going to compare with the threshold value. Threshold value is 0.05. Okay. Now, how we are going to give the conclusion? How we are going to interpret the findings? If the p-value is less than the threshold, what are the tests that you are going to conduct in order to understand whether your data is distributed normally or not? We are going to come up with conclusion part. If the p-value is less than the threshold, means what are the tests that you're conducting it? If the p-value is less than 0.05, we reject the null hypothesis. Means the sample is drawn from a normal distributed population. We are going to reject this particular null hypothesis. In case, if the p-value is greater than the threshold, that is greater than 0.05, we are going to mention that, what, mouse, 1 minute. Yeah, I just. If the p-value is greater than the threshold, we fail to reject the null hypothesis. So this is how we are going to report as a part of your normality distribution of the data here. So before going to conduct a one sample t-test, what we'll do it? We'll verify whether our data is normally distributed or not. I request all of you to please open your data set. First, open your JAMOVI. I'm shifting from PPT to JAMOVI. I hope my screen is visible. Yes. Is my JAMOVI is visible? I have opened the application of JAMOVI.
Yes, sir.
Yeah, okay. Now I'm just importing the data. Just please import the data. First one we are importing, name of the file is t-test. The name of the file is t-test. I hope all of you must have downloaded the data set that I have given to you all. Please download the data set. Title of the file is t-test. Title of the file is t-test. Now in this particular data set, we have 5 variables: ID, gender, athlete, height, mile, minute, duration. So we have data of around 435 responses, nearly 435 responses we have it, and 5 variables we have it. I can say that at least.
Where we have the data sets,
Sorry.
a data set from where we can have this for t-test.
I have copied it in your WhatsApp, sir. Please check your WhatsApp group. Okay. I think from the beginning, madam was also asking download your data. Please check it to your WhatsApp group. I have shared two files, two SPSS files. You cannot open the SPSS file if you don't have SPSS software, but one can import the file in JAMOVI. I request all the members. I'm just giving 30 seconds. Please download your data from the WhatsApp group. I hope all of you are ready. Shall we go ahead?
Yes, sir.
Yeah, please. Yeah. Now, as a researcher, first what you have to do is once we import the data, please check it whether how we have entered the data, what kind of variables that you have it. I have gender, athlete, height, mile per minute, duration. Second one, how I have given coding. Were there any problems with the data set? So it's a gender, nominal, male, I have given 0. Please remember how we have given coding. Most of the data sets, it is not always compulsory that male is 1 and female is 2. As a researcher, you have choices, but you should know how we have given coding part. Okay. How we have given coding, one has to have clarity with the next variable, athlete category. We have again non-athlete, athlete. Non-athlete is 0, athlete is 1. Next variable, we have height. It is a continuous data, that to decimal data. Next variable we have it as mile per minute duration. Again, it is a continuous data, decimal data we have. So I just verified my data. I don't think there is any problem with that. Okay. So after confirming the data set that you have it, please go to analyze, exploration. There is a first option called descriptives. We have first option called descriptives. Now, when it comes to our one sample t-test, our hypothesis, null hypothesis was we are just taking the null hypothesis as a part of the one sample t-test. We are choosing the height. Okay. Now for the height, I need to check whether this particular variable data is distributed normally or not. So please select height, drag and drop it here. Select the variable that you want to test it. Either you can drag and drop it here, or you can select and click on this particular arrow button. Now we got it height. We got the descriptive statistics like mean value, median value, standard deviation value. Just come to the statistics. Please come to the statistics. Scroll your cursor down. And here I am able to see standard deviation, missing values, mean, median. Okay. There is option called normality test. What was our hypothesis? The sample is drawn from a normally distributed population. That was our null hypothesis. So we are checking this particular null hypothesis with the help of Sperrio-Wilkie test. Okay. Now, please click on Sperrio-Wilkie test. Just click on Sperrio-Wilkie test. As I mentioned yesterday, right now this particular data is in the form of column wise. Now, if I want to make changes, I can put it in the form of row wise so that I can see the entire data in proper manner. So it depends on the researcher how you would like to see the data, whether you want to see row wise, column wise. So it give me more clarity. I can be able to see that Spereo-Wilkie test, we have two values. As I mentioned yesterday, we are going to rely on the p value. Spereo-Wilkie test, p value here, p. Instead of w, we are going to take the values of p. Okay. Now, coming to our threshold value. Whenever you're going to practice this, you can please look at my PPTs. I'm going to share all PPTs on the last day. With reference to day one, I have already shared it. I also shared very interesting, very good reading material. There is one book, ebook on learning statistics with JAMOVI. If your time permits, please take the book, print out of the particular book, and you can practice it. Okay. Now, what is our threshold value? P value is less than the threshold value. If the P value is less than the threshold value, we reject the null hypothesis. Means if it is less than 0.05, we are going to reject it. Now come to our hypothesis, our test result. It is 0.07. So how to understand this one? What it indicates? Anyone?
Data is not normal, sir.
Data is not?
Normal, sir.
Data is normal or not
It
normal?
does not normal because it is greater than the 0.05. Oh, okay. It is not significant. Oh, sir, normal. It shows the normal data.
Okay.
We failed to reject
Okay.
null hypothesis.
We fail to reject
Yes,
the null
yes, yes.
hypothesis. It means that the sample is drawn from
data
a
is normal.
normally distributed. Means our data is
Yes,
distributed
yes.
normally. So we are going to conclude like this. Since Spereo-Wilkie value is greater than 0.05, we can conclude the assumption of the normality is not violated. Means our data is distributed normally. So one can write as a part of your research paper as a thesis, small line about your normal distribution of the data. Okay. That way we can able to conclude it. Now, so we are able to fulfill our assumption, and we also have one data, that is height is one variable. It is a continuous data, and I'm saying that our data is collected with the help of random sampling. So we are able to fulfill all the assumptions. Now there is one more option here as a part of Spereo-Wilkie test. Now, for example, what happens is the middle of the window gone, the data processing window gone. Every time I don't need to go and start from the beginning. What you can do is you select this particular output result, keep your cursor here, double click, and you'll get it the previous stage, that is processing. I'm just repeating again. The processing window gone back means I'm not able to see the processing window right now here. In order to see the processing window, you don't need to do it again from the beginning. You don't need to start with A. If you want to go back to the previous stage, that processing window, just keep your cursor near results. Okay. And just click on it. And this processing window will come back again. Okay. The processing window come back again. Now, in addition to Spereo-Wilkie test, we also have certain plots. As we are doing for the first time, we'll also explore for this particular height, how histogram is presenting, whether it's showing any kind of outliers, how data is distributed. One can able to see that bell-shaped curve. Okay, so I can able to understand that data is distributed normally. I can also keep density, smoothing curve, like how it indicates clearly that our data is distributed normally. In order to support it further, I can also see QQ plots. QQ plots, like this is the diagonal line. One can able to see that my data is clustered around the diagonal line. There are certain outliers, but still it is not affecting our normal distribution of the data. Okay. Second, I can also prepare box plot. Now, coming to the box plot, please look at my PPT here. Now, even yesterday also I mentioned about it. Box plot, we have certain first quartile, second quartile, third quartiles. One can able to see there are from this particular data to this particular data point, this is 25 percentile. From this particular horizontal line, as you can see, from this particular line to this particular line, this is 20 percentile of your data. Okay. And from this line to this line, 50% of the data. This is a mid value, middle point. Okay. From this particular point to this particular point, that is 75% of the data. From this particular point to this particular point, we have 100% of the data we have. Now, in case if there are any outliers, it will show outside of the horizontal line. Like for example, here it's showing that 326. Please remember this particular data. Please remember this 326 is nothing but this is the respondent number 326. 300 326. 326 height is 84.41. Means we have basically we have around 65, 66, even 70 also, 77 also we have it. But this is 84 means is deviant. One can able to see that it is more deviant from the mean value. Let me show you another value. 397. Just to understand why it is considered as outlier. Okay. 397. For every data, we are not going to check it. Just for the first test, I'm just wanted to explain in detail every step. 397. Again, here 84.16. 407, it is 83.75. Just for your sake. Right now, what I'm going to do is 397. Here, I'm just 84 is here. Right now, I'm converting this data as 60. I converted as 60. Okay. Please see here. You're not able to see 397 data. The best part of JAMOVI is that it is completely dynamic. The moment I change it here, by default, by automatically it changes entire data. You're not able to see here right now 397 data set. Means one outlier we have, I have manipulated. That manipulation is not the correct one. For example, imagine that your data is not distributed normally. What are the alternatives? There are two alternatives. First alternative is you can increase your sample size. In case if your sample size is good enough, you can take the call to delete that particular respondent number. If it is disturbing your normality distribution of the, I request the participants, Professor Divya, I think it is. Yeah. Now, if it is disturbing your normality distribution of the data, and if your sample size is good enough, you can take the call to delete that particular outlier. But if your sample size is small, instead of deleting it, collect the more data. So these are the two options are available. Okay. I hope the point is very clear. Now, next. We have conducted normality distribution. Our data is normally distributed. Okay. Now, next, go to the next part. Now, as we have fulfilled all the assumptions, we are going with conducting one sample t-test. We are going to conduct the one sample t-test. In order to conduct one sample t-test, as a part of analysis, we have first option t-test. Go to t-test. In that, we have one sample t-test. As a part of the analysis, we have t-test, ANOVA, regression, we have it. Go to t-test. Within that, we have one sample t-test. Just select it. Just select the one sample t-test. And now, which variable that you are taking it? As per our hypothesis, we are going to test with the height. Okay. Select the height and put it under dependent variable. Put it under dependent variable. Now, here we got the result. Next one. This is a descriptive statistics. We have got one sample t-test. Now, I also wanted to see mean difference. Mean difference between sample mean and population mean. Population mean and sample mean. So I need to understand, was there any difference between population mean and sample mean? So just select it. So we got the difference between sample mean and population mean. Confidence interval. Please click on the mean difference. Confidence interval. Second important point here. Test value. test value. Now, coming to the test value, please look at your hypothesis. Our hypothesis was population mean was 66.5. Our population mean is 66.5. So we need to keep 66.5 is a population mean. Our population mean is 66.5. Now just look at here. Now we have selected t-test. We have selected mean difference. We have selected confidence interval. I'm going to explain one by one. And descriptive statistics for this particular height, this particular variable. If you want to prepare descriptive plots, one can prepare it. Okay. Now coming to the data interpretation part. Coming to the data interpretation part, we'll go with step by step. There are two important outputs, two important results we have it. First one is descriptives. We have total 435 respondents. However, we got the data only for 408, means there are certain missing values, we have it. So total number of people responded to this particular question was 408. For 408, an average age, we have collected data from 435 people. Out of 435 people, around there are a couple of missing values. Total number of people responded is 408. For the 408, if you look at the average height, it is 68. On average, in Gujarat, the data that we have collected from 435 people, that is 408 people, the average height is 68. Okay, so they got this mean value. Now coming to the second test result, that is one sample t-test that we are conducting it. Now, as a part of one sample t-test result, we need to see three important things. We need to see three important points here. First point, mean value, sample mean value is 68. Okay, we got the difference, mean difference is 1.45, means 66.5 minus 68, you will get it 1.47, means there is a difference between population mean and sample mean 1.57 inches. Overall, on average, Gujarat population height is 66.5, but the data that are collected from 435 people, that is 408 people, their average height is 68, means one can able to see the difference of 1.47 inches difference between sample mean and population mean. But I want to know what are the difference that you are seeing it. Is it occurred by chance? Was really there is a significant difference? So in order to understand that, we have conducted one sample t-test. Now coming to our p-value. Our p-value is less than 0.01. Now, when it comes to the p-value, for any test, given the observed data set, the p-value is the smallest level for which null hypothesis is rejected. Now, if you want to understand how to take the call as a part of the p-value, if the p-value that is less than point alpha value, that is we are going to reject the null hypothesis. Like for example, p-value is less than 0.05, 0.001. What is this 0.01, 0.05? These are the significant level. Now, as a social scientist, most of the social scientists, what happens is we'll go with 0.05 as a significant value. Now, when it comes to the scholars coming from science, medical science, health practitioners, most of the scientists, those are conducting experiments because they can't take the risk. 0.5 is a really big thing. So they'll go with 0.001, 0.01. Means when it comes, for example, we have as a part of the vaccination, Covishield and Covaxin. If somebody says that we are only confident 95% and the remaining 5% we are not confident, means 0.05, there is a margin of error. One can able to see that. When it comes to the health, when it comes to the life, 0.05 is a big thing. We can't take that much risk. But most of the scientists, medical science practitioners, they'll go with at least, you're not coming with any error, but there is scope. There can be some kind of margin of error can take place. So 0.001, 0.01, scientists, scholars, scientists, they'll go with. But when it comes to the management, social scientists, humanities, you'll go with 0.05. Okay. If the p-value is less than 0.05, it means statistically significant, means we are going to reject the null hypothesis. In case, if the p-value is greater than 0.05, not statistically significant, so we are failed to reject the null hypothesis. Now, having understanding about this theoretical point, now just please look at our p-value here. What is our p-value here? Our p-value is less than 0.05. It means what it indicates. Means there is a statistical significant difference between population mean as well as sample mean. So how one can write it as a part of your report writing? Our hypothesis population value was 66.5 inches. The average height of the overall adult population in the Gujarat state is less than 0.001, means less than 0.05. We reject the null hypothesis that the mean height of the sample mean, I think there's some error here. The mean height of the sample mean is equal to the hypothesis population mean, that is 66.5, and conclude that the mean height is statistically different than 66.5. Based on the results, we can state the following. There is a significant difference in the sample mean height of the adult population in the Gujarat and the overall adult population in the Gujarat. Means you're trying to compare the population mean and sample mean, and you're able to come up with the conclusion part. The average sample mean height of the adult population in Gujarat state is about 1.5. So how much difference we have it? As I just rounded off it. Instead of saying 1.47, I just rounded it like 1.5 inches taller than the adult population. And how much your confidence interval? 95% confidence interval. Now, what it is, this confidence interval? Now here, I'm saying that there is a difference of 1.57, 1.5. For the sake of simplification, just round it. 1.5 mean difference between sample mean and population mean. Now, as a researcher, I'm confident that lower level means an average 1.5 mean difference between the sample mean and population mean. But if you want to go with the confidence interval, 95% confidence interval means lower level, lower bound means the difference 1.5 you are saying, lower level is 0.95, upper level is 1.99. Means what are the difference? An average 95% confidence interval we are seeing 1.47, but there is also lower level is 0.95, higher level is 1.99. So we can able to say that as a researcher confidently, this is the lower level, this is upper bound. There is a mean difference is 1.5 and it's statistically significant. One can able to see difference between sample mean and hypothesis value of population mean. So this is all about one sample t-test. This is all about one sample t-test. I hope I'm able to make it sense. Is it clear to all? Shall we go ahead with the next?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Okay, thank you. Next one. Coming to the next stage, independent sample t-test. Now coming to the independent sample t-test, it is a parametric test. It compares the means of two independent groups in order to determine whether there is statistical evidence that the associated population means are significantly different. Now, just like the one sample t-test, it is an independent sample t-test is a parametric test. And it compares the means of two independent groups in order to determine whether there is statistical evidence. So basically, you're going to take two independent groups, like for example, gender, male, female. There should be two groups. In case, imagine that there are three groups, like male, female, and we also have transgender, we also have LGBT communities. So in that case, one cannot go with one sample, independent sample t-test. One has to go with ANOVA test. Now, in order to conduct the independent sample t-test, we need to have one dependent variable, one independent variable. Independent sample t-test is also known as two sample t-test, unpaired sample t-test. It is also known as two sample t-test, unpaired sample t-test. Now, when it comes to the assumptions, when it comes to the data requirements assumptions, as I mentioned it, we need to have one dependent variable, one independent variable. Point number 2, you are going to have dependent and independent, but one also need to ensure that the dependent variable must be continuous. It must be either interval data or ratio data. Basically, it is a metric or quantitative data. Whereas when it comes to the independent variable, it must be categorical data. Secondly, it must consist of only two categories. I'm just repeating again. As a researcher, if you want to conduct independent sample t-test, we need two data variables. One is dependent variable, second one is independent variable. And point number two, the dependent variable must be interval or ratio data, whereas independent variable must be categorical. It means it can be nominal data, it can be ordinal data. Thing is, you should have two categories. You should have two categories. Now, two categories means that basically is the nominal data. Whenever you're going to have ordinal data, one can go with a non-parametric test. I'll discuss it later on. Now, the cases that have values on both the dependent and independent variables means there must be cases. Like, for example, dependent variable must have data. Independent variable also must have data. Two categories. These are the commons like random sample, independence of observation, normality distribution. Another unique point is that homogeneity of the variance. Now, there are two groups, male and female. You are assuming that there is an equal variance is going to take place between the male and female. Whatever the changes are happening as a part of your data, you are assuming that homogeneity of the variance. You are approximately assuming that there won't be much changes between males and females as a part of your data set you have. Now, one more important point. Earlier, we have conducted, in order to complete one sample t-test, we have conducted normality test, and we also conducted one sample t-test. Whereas when it comes to conducting independent sample t-test, we are going to conduct normality test, we are going to conduct a homogeneity test, and we are going to conduct independent sample t-test. Now, what happens is, as a researcher, you are assuming there is a homogeneity between the male and female. Means whatever the changes happening, same level of equal variance is happening between the groups in terms of their performance, in terms of height, whatever the dependent variable that you take it, you are assuming that there is equal variance among the groups. Now, when it comes to the homogeneity of the variance, the null hypothesis of this test is equal variance assumed. That is, there are no significant differences between the sample variances of two independent groups. For example, we test for homogeneity of the variance using the Levian's test. We are going to take the help of Levian's test to understand whether within our data, whether homogeneity of the variance is assumed or not. The Levian's test was not statistically significant different. If the p-value is greater than 0.05, Levian's test was not statistically significant, means there are no significant differences. Therefore, this indicates that our data satisfy the assumption, means our data must be, the homogeneity of the variance test value must be greater than 0.05 to ensure that our homogeneity of the variance is assumed. In case, if the variance Levian's test value is less than 0.05, it indicates that there are significant differences are there. Now, it is very important point here. Why one has to conduct homogeneity of the variance? Now, in case if you are able to fulfill the assumption like homogeneity of the variance is assumed, if you are satisfied that you are going to conduct independent sample t-test, you are going to conduct independent sample t-test. In case if the assumption is violated, if the p-value is less than 0.05, means homogeneity of the variance is not satisfied. In that case, we are going to take the values of the Welch test. We are going to take the values of the Welch test. Instead of going for non-parametric test, we have one more option, Welch test, which is considered as the more robust whenever it comes to your homogeneity of the variance is not assumed. One can rely on the Welch test. I'll discuss it rest of the stuff later. Come to the data set. Please open the same data. Please open the same data set. So we have data with us coming to our null hypothesis. There is no difference in number of millimiles per minute duration. So right now I have different data set. My data is like this. We have gender is a one variable. Gender is one variable. We have two categories, male and female. Athlete is another category. We have non-athlete, athlete. Now, coming to the data set, we need to have two variables. One is dependent variable. Second one is independent variable. Dependent variable must be continuous data. So we have two options here. One is height is continuous data and miles per minute duration is continuous data. Now, my null hypothesis is that I'm taking two variables. One is athlete and non-athlete category. There is an independent variable. We have two categories. Second one, in dependent variable, I'm taking miles per minute duration. Means I just want to know whether the person belongs to athlete category and non-athlete category. Are they having any kind of difference when it comes to going for number of miles per minute duration? I'm just repeating again. I just want to compare whether the person belongs to athlete category and non-athlete category having any kind of differences when it comes to going for number of miles per minute duration. So for 1 minute, how many miles a person can go? The person belongs to athlete category, whether he can go more than non-athlete category or not. Now, when it comes to my null hypothesis, what I'm saying that there is no significant difference between athlete and non-athlete category. What happened to this? Just 1 minute. Yeah. My null hypothesis is that there is no significant differences between athlete and non-athlete category when it comes to the number of miles per minute duration. Whereas my alternative hypothesis, there is a significant difference between athlete and non-athlete category when we compare with the number of miles per minute duration. Now, as I just want to conduct it. So we're not going to conduct a normality test. I'm sure all of you knows about it, right? How to conduct the normality test. Okay. Now we are going directly to conduct independent sample t-test. We are going to conduct independent sample test. Now, in order to conduct the independent sample t-test, please go to analyze. Please go to analyze. First option we have exploration. Second option we have t-test. Please select the t-test. Please select the t-test. Professor Chandra Kumar. So please select the independent sample t-test. Now we have selected independent sample t-test. Now you can see that middle of the window is a data processing window. Here we have to select the variable. Mile per minute duration is a dependent variable. It is a continuous data. We are assuming that data is distributed. I'm not conducting normality test. Okay. If you want to conduct it, we can here also you can conduct it. So I have selected mile per minute duration and a dependent variable. Athlete and non-athlete category. That also we have it. So we have two categories. There is independent variable. So I'm going to keep athlete and non-athlete as a grouping variable. Okay. Now coming to the results here. Please look at the bottom. So right now we got independent sample t-test result. Now coming to the test, we are conducting t-test, that is independent sample t-test. By default is already there, t-test. I want to understand mean difference. Is there any difference between athlete and non-athlete? If there is a difference, how much difference we have it? Second one, I also want to know confidence interval, 95% confidence interval. That also we got it. Second one, I'll talk about it. Effect size. Just right now for timing, just click on the effect size. Just click on the effect size. Then descriptives. Just click on the descriptives. Just understand whether data is distributed normally or not. Okay. So we got normality distribution. Our data is not distributed normally, but still we are going ahead. Okay. Right now, don't consider this one. But as a researcher, one has to report whether your data is distributed normally or not. That is one of the important steps. Now, homogeneity of the test. We have to conduct a homogeneity of the test. QQ plots. Okay. Now, what you can do, just unclick normality test and unclick QQ plots. We are going to look at 3 data results that we got it. First one, whenever you start writing your data analysis part, after completion of any of the test. First, you should talk about basic statistics, like descriptive statistics. So first, you should give the overview of what is our data that you have collected it, how many people are there, what are the differences we have. Now, we have 435 people. Out of 435 people, we got, let me see, are there any missing values? Okay, now 226 plus 166, we got 3 plus 8, 308, 392, around 392 people there are, okay? Now this is the total number of the people. Out of that, 166 people belongs to athlete category, 226 people belongs to non-athlete category. So this is a basic overview as a researcher one has to provide before talking about statistical results. Now, for this particular population, the people belongs to athlete category, the mean value is 413. 400 minutes. We're not able to see this one. 1 minute. Please come here. What is the data set? We have it. So we have miles per minute duration. We have miles per minute duration. These are the miles per minute duration we have it. Based on this particular test results, you can able to see that mean difference 135 miles per minute duration we have it. I think there is something wrong this particular data. 1 minute. Just give me 1 minute. Let me choose height. I'm just choosing the height instead of miles per minute duration. Now just look at here. I'm not able to understand the data. There's some changes here. Now looking at the athlete and non-athlete category. The people belongs to athlete category on average height is 69.3. The people belongs to athlete category. They belongs to their average height is 69.3 inches. Whereas the people belongs to non-athlete category, on average height is 67. Now I want to see whether are there any differences. Now when it comes to the differences, I can able to see that 2.24. Don't worry about the minus plus here. It depends on the how you are putting the values. That way it makes a difference. Now difference is between athlete and non-athlete categories 2.24 inches. 2.24 inches difference we have between the athlete and non-athlete category. Now, I just want to know what are the difference that I'm seeing it, whether it's statistically significant different. So in order to understand whether these particular results are happened by chance or there's statistically some difference, one can able to see that. Now, looking at the p-value, I can able to see that p-value is less than 0.05. It means there is a statistically significant difference between athlete and non-athlete category when it comes to their height. Second one, as I got the confidence interval, that is, though I'm saying that 2.24 is the mean difference between athlete and non-athlete when it comes to their height. Lower bound is lower bound is 3.26 and upper level is, it should be opposite side. It should be opposite side. Okay. It should be opposite side. Like, for example, lower level is 1.23, upper level is 3.26. Means what are the mean difference that you are seeing for the total population of the people for the 408 people. 408 people. Lower level is 1.23, upper level is 3.26. Height difference, mean height difference between athlete and non-athlete. Now, what I can do is, as we also have gender, instead of height, I can also look at the gender wise. I just want to know whether gender is having any kind of influence. The people belongs to male category. whether it's having any kind of influence on their height. I want to see whether I can able to compare the height based on the gender. If you look at our basic descriptive statistics, mean height for the males is 70. The people belongs to male category, on average their height is 70. Whereas the people belongs to female category, on average height is 65.5. If you look at the test results, independent sample t-test, mean difference is 4.8, means on average I can able to see 5 difference between males and females just because they belongs to male category. Their average mean height is 70, and whereas when it comes to female category, average height is 60. Average, I'm talking about mean value 60 point. Now I just want to know, well, whatever the difference I'm seeing it, whether it's statistically significant difference, our p-value is less than 0.05, means there is a statistically significant difference between gender and female when it comes to their height. Now, one important point here one has to see. What is that? Before going to the conclusion, one has to see results of the homogeneity of the test. What I mentioned here as a part of the homogeneity of the test, the Levian's test not statistically significant, means it should not be statistically significant, means our p-value should be greater than 0.05. If you look at our homogeneity of the test, our value is 0.08, means it is greater than 0.05. It means it is not statistically significant difference, means we are assuming that there is equal variance among the groups. Please look at here. The Levian's test was not statistically significant, means our p-value is greater than 0.05. Therefore, this indicates that our data satisfy the assumption of homogeneity of the variance, means we are assuming that our data is distributed normally, means we are satisfying the homogeneity of the variance. So we are going to take the results of students test. Okay. Now we are going to take the results of this particular test. Now, hypothetically, imagine that our assumption Levian's test value is less than 0.05. Hypothetically, imagine that this particular value is less than 0.05. Now, instead of taking the t-test value, we are going to take the values of Welch test. Welch test, again, here it is less than 0.05, means there is a statistical significant difference between male and female when it comes to their height. Similarly, we also checked with number of miles per minute duration as well. I hope I'm able to make it clear to you all. Is it clear?
Yes, sir. Yeah.
Yes, sir.
Okay. So last one, we are going with paid sample t-test. You can close this particular data set. Open the last data set. That is another data set that I have given to you. I think one more important point I just missed to inform you. As you can see my PPT here, there is something called effect size.
The PPT is not visible, it seems.
Oh, okay. 1 minute. Just 1 minute. Yes. I hope my PPT is visible.
Yes, sir.
We also done something related to effect size. There is one more figure with reference to effect size. We got confidence interval, we got p-value, significant results. But still, if you want to highlight your findings of the study, you got significant results, but how much effect it is, how much effect size it is there. So you want to talk more in clarity. If the effect size is less than 0.05, if the p-value is less than 0.05, it indicates that medium effect. It indicates that, for example, an effect of 0.05, it is a medium effect. If it is less than 0.02, it is a small effect. If it is less than 0.05, it is a medium effect. If it is between medium and greater effect, that is less than 0.08, it means great effect. So one more line, one can able to add it as a part of your conclusion part. despite, as we are talking about, there is a significant difference between mean and significant difference between gender in terms of their height. You can also say that the effect size is great effect. So just one more line, one can add it. It's not required to talk effect size. Very few scholars, they'll write about it effect size. If you can able to write it, that is well and good in that case. Okay. Next one. Paired sample t-test. It is a parametric test. It compares the means of two measures taken from the same individual or same object or related items. Now, when it comes to the paired sample t-test, it compares the means of two measurements taken from the same individual. For example, Dr. Don't mind, I'm not pronouncing correctly. Dr. Muradwaj. Okay. Imagine that he's collecting data from his students and is taking their results, test results, like max score, science score. Max score, math score, and science score. These are the two incidents. These are the two subjects score. And you want to measure it. Are there any difference between math test score and science test score? Now we have Dr. Chandra Kumar, and he wanted to understand before attending this particular JAMOVI training program. Imagine that he was attending some faculty development program, and he wanted to see what kind of improvement he's having it as a part of the feedback from his students. As you can see at the year ending, most of our institutions, they'll take feedback from the students to assess the performance of the faculty members. In addition to your contributions in terms of publications, in terms of your research writing, whatever it is, projects and all, they'll also collect the feedback from your students. Now, before attending faculty development program, and what was the teaching style that you have it, and you got the color, you have collected data from your students to understand how you are teaching it, what kind of pedagogy that you have included it. After attending some faculty development program about educational pedagogy, teaching pedagogy, generally different kind of usage of various tools. After attending the program, again, you're collecting data from your students. So you want to understand pre-intervention, post-intervention. You want to see the impact of your intervention, how effective this particular intervention is there. Maybe, for example, if somebody is coming from sociology, some psychology, from psychology people. So you must be using some psychological interventions, some counseling techniques, some intervention strategies. Before giving intervention, after giving intervention, you want to see whether is there any kind of impact on your clients in terms of their psychological behavior, in terms of their understanding about their life. So it depends on the context. One can able to conduct pre-intervention, pro-intervention test. Means you are collecting data one time before the intervention, and you will be collecting data after giving the intervention. Means basically you try to see the difference between pre and post. So that can also be one kind of context for conducting paid sample t-test. I'm just repeating again when to conduct the paid sample t-test. If you want to conduct the paid sample t-test, there must be two measurements. There must be two values. As I mentioned it can be like height and weight. It can be like math test score, science test, not height and weight, sorry. It must be like math test score, science test score. You're collecting data from the same person. And you're also collecting pre-test, post-test. So you're trying to situation, even height and weight, I don't think there's any problem with that. One can able to conduct paid sample t-test with that. Now, I just want to see, as a part of this particular data set, what are the data requirements are there? Dependent variable must be continuous data. We required dependent variables that must be two continuous data. And normality distribution of the data, a random sample of the population. There should not be any outliers. Now coming to the data set, please look at our data set here. I'll talk about hypothesis. Please open your JAMOVI. Please open our JAMOVI. Okay. Now we are importing the second data set I have given you today. We are importing the second data set. I think it was coding book 4, something a title was there. Please import the data, second data that I have given you today. Okay. Now, coming to our hypothesis. Our hypothesis is there is no difference in mean pre and post marks of teaching intervention. Means you are saying that your null hypothesis is that there is no difference in mean pre and post marks of teaching intervention. Means before giving the intervention, you have selected the marks of the students. And after the intervention, again, you have collected the feedback from your students and you are seeing the difference between pre and post marks. Second, alternative hypothesis, there is a difference mean pre and post marks of teaching intervention. For this particular hypothesis, we are going to test it. Now, what you have to do is here, you have to test the normality test. We all know how to conduct the normality test for that, right? Now, we are going directly to conduct paired sample t-test. Go to analyze. Go to analyze. There is option called t-test. There is option called t-test.
आओ इधर आओ.
And within that, there is option called paired sample t-test. Select paired sample t-test. And you can choose the options pre-test,
अबे वर्कशॉप चला, आधे घंटे बाद बात करते हैं, ठीक है?
pre-test and post-test. So we got the results here. Now, t-test results, we are going to go ahead. I want to see the mean difference between pre and post. I want to see the confidence values, confidence interval results. I also wanted to see the effect size. I also wanted to see the descriptives. Okay. Now, coming to the results, we have two results. First one is a descriptive. There are total 20 respondents. If you look at the marks, if you look at the feedback, what are we called? Marks of feedback. Before the intervention, you collected data from your students. Mean value is 18.4. After going for the training, after going for some intervention, after giving some intervention, post-intervention marks are 20.40. Post-intervention results, 20.4. Now, this is the mean value one can able to understand. Now I can able to see there is a difference. How much difference? 2.05. 2.05 is the mean difference between pre and post intervention marks results. One can able to see that. Now I just want to know whether this particular 2.05 marks is occurred by chance with statistically significant difference we have. Now if you look at our p-value is less than 0.05. It means whatever you are seeing 2.05 mean difference, it is statistically, there is huge difference between pre and post marks results. Pre and post mark results. Now, when it comes to the confidence interval, you are saying that difference is point. Don't look, see why we are getting marks minus. Let's take, for example, I'll do it again. I'll take post first, minus first. So that is the reason I mentioned that you don't need to worry about the plus or minus point. Okay. Plus or minus, you should not worry about it when it comes to one sample t-test, independent sample t-test, paired sample t-test. Just look at the results here. Now there is no minus. Post minus pre. So there is a difference of 2.05. And when it comes to the lower bound, one can able to see 0.7. Though there is a difference of 2.05 mean difference. But when it comes to the lower bound, 0.7. When it comes to the upper bound, means there are candidates like one of the faculty member, he got mean difference of pre and post 3.38. There are also faculty members, those who got mean difference, lowest difference. Instead of 2, lowest difference is 0.72. Difference between pre and post. I hope I'm able to convey properly the correct message. There are 20 faculty members. Those attended intervention program, they have came up with some intervention. The outcome of the intervention is they got an average 2.05 mean difference between pre and post. But there are also candidates. There are 1 or 2 candidates, maybe a couple of candidates. They got instead of 2 difference, 0.7 only. There is a lowest level is 0.7. Whereas there are candidates more than 2.05. Means there are some candidates, the intervention really worked for them. It went up to 3.38. So as a researcher with the confidence interval level, you are able to say that On average, 95%, there are 2.05 mean difference one can able to see as a part of their intervention level. I hope, is it clear to all? Yes, no?
Yes, sir. It is
Yes, sir.
Clear, sir, clear.
Yeah,
Yes, sir.
yeah, thank you. Now, next one is, I need volunteers as a part of the demonstration. I can cover more number of topics on a single day, but covering the topic and having 1 or 2 people demonstration, that is very important. Feel free to demonstrate it, just demo it. So that is one of the important objective of this particular workshop. I don't see majority of you are doing simultaneously along with me, but if somebody can practice along with me, that will be much more beneficial, so that you won't be able to forget it. Is there any volunteer who can practice right now? Who can share your screen?
Shall I do, say?
Please, please, please. You can share your screen, you can practice it.
Sir, you can share it. You can share your screen. Sir.
Please ensure that every day last 10 minutes, we are going to have hands-on practice. I want someone, at least, if not all, at least 1 or 2 candidates, they should demo it. They should conduct demo. Okay. So that we will understand that organizer point of view, as a resource person point of view, we'll understand that we are able to do justice to you all. Okay. Was it clear so far? All the concepts, what have we covered? Instead of simply saying yes, no. Was it clear to all?
Yes. Yes, sir. It is clear.
Yes, sir.
Okay. Dr. Lakshman, please. Thank you. Which test you are going to conduct, sir? I request all the members, please see our colleague, he is doing it. You can also select conference interval, sir. That is also one of the important stuff. It's not effect size. Effect size also you can select it, but mean difference conference interval, you must talk about it. Under additional statistics, below mean difference, we have conference interval, not effect size conference interval. Effect size conference interval, if you want to talk further, that is up to you. But mean difference conference interval, you can see my cursor. Yes, please select it. Yes. Effect size conference interval, that is your choice. Okay, that is up to you. And can also select descriptives. Yes. Homogeneity test. Yes, select a homogeneity test. Yes. Yeah. So we got the results. Now our test value is 0.072, homogeneity of the value. Imagine that our test value is less than 0.05. What to do? What to do next? Our assumption value, that is Levian's test values, imagine that is less than 0.05. What we have to do in that case? In that case, instead of relying on the t-test, you can go with Welch test. If you want to conduct independent sample test, you can go with Welch test. If you decided that you want to go with non-parametric test, one can go with Mann-Whitney test. I'll talk about it later on, Mann-Whitney. Okay. All non-parametric test, I'll discuss it later on. Right now, we are doing it only independent sample test. Very good, sir. Thank you so much. I hope it is clear to you, sir. Not only conducting, even the values, how one can interpret the each and every value. Dr. Lakshman, I think this was Dr. Lakshman. Dr. Lakshman.
Dr. Lakshman, you can unmute your system.
I just want to know, it's not just only performing it. Are you able to understand each and every value that you are seeing on your screen? Not only Lakshman, Dr. Lakshman, any other person. If there is any value, if you want me to understand, just let me know. If you have any questions, I can explain further. But from the layman point of view, what are the basic things are required? I just mentioned everything in as a part of it. Okay. Thank you. Thank you so much. Next candidate, anyone else would like to conduct any other test? Anybody would like to conduct the
This
test?
screen, sir, that is why I couldn't speak. It was behind the screen.
Sorry, sir.
The sound was behind the screen. I couldn't turn it on. That is why I couldn't speak.
No problem. No problem. Thank you for performing it. Thank you so much.
I'm
My
doing
question-
in SPSS, sir. It is first time in JAMOVI. And I do feel that this one is better than that of SPSS in many respects.
Okay.
Thank
See,
you.
I have to say thanks to Vijay ma'am. What happens is we used to rush, we used to cover so many topics on single day. As it is 7 days, we have sufficient time to discuss every topic in detail. And we can cover it. We can also have demo sessions, practice sessions as a part of this particular program. Okay.
Sure.
So otherwise I can cover as many topics as possible in single day, and so that you'll get confused. Now what happens is those who want to listen, those who want to once again watch the recorded session, you can watch it, you can practice it. So every day 3 topics, every day couple of topics is very important, right? Yes. Anybody next?
No issue. We can, like, everything is being recorded. I'll be sharing you the recording. If you are facing any network issue, there is no problem. You can see it again and you can practice at your home.
So can I have one more candidate, last candidate, who can present the demo? Are there any candidates who are willing to present it? I request, is there anyone willing to
Okay,
take
we
part?
doing it.
So if you don't want to practice it, I think,
Shall I present the paid sample test too?
yes, sir, you can do that. If nobody is coming up, you can end the session or you can practice. You can do it. Sir.
Yes,
Yes.
you can share your screen. Let everyone see it once again.
Yes. Coding book 4. Okay. Very good. Okay. Descriptives, you can select the descriptives. Yes, we are able to complete it. So we got the results, mean difference, pre and post. And mean difference we got 2.05 is, and effect size, as it is near to 8, one can able to see in between medium and great effect size, one can able to see. So you can also talk about how much significance value we have it, how much effect size also we have it. So both ways one can able to explain the data that you have it as a part of your data analysis and interpretation part. Okay.
Thank you.
Yeah. Please. I'll share my screen once again. I just want to show one of the book. Let me share my screen with you all. I'm sharing my screen. Just 1 minute. I've shared 2 important books. One is Learning Statistics with JAMOVI, and one is something related to education background point of advanced level we have it. So I request please open it whenever. If you don't have time to read right now, don't worry about it. But please explore this particular book. Look at the context, content of this particular book. Every test is explained and step by step how one can conduct it. Generally, people won't share this kind of ebooks. but this particular ebook is going to really help you in terms of understanding the concept, in order to understand the assumptions. So just look at the content, and if you feel it's really very important, you can also take the printout of this particular book. Okay, so it is 519 pages. You can take 20 pages, 20 pages. Concept wise also you can take the printout. Second, another important book that I have shared. First, I suggest you to go through this particular book. Second one, design and analysis in educational research with reference to specific subject wise. There are certain ANOVA results. There are so many tests are with reference to ANOVA. Very important book. Very helpful. Step by step is given everything. Find some time to explore it, what this particular book is all about it. If you feel it's really, really helpful, you can take the printout of this particular book as well. Okay. So this is all about from today. I'm just stopping the session. Vijay ma'am, from my side, we have completed. And from tomorrow, I don't think we'll get more time even to practice also. So tomorrow we'll start with ANOVA, and as a part of ANOVA test, one-way ANOVA, two-way ANOVA, and chi-square test. I don't think tomorrow we'll have this much time to practice it as well. But I'll be more happy even if you pass time, you can do it practice. Okay.
Can we do
So one-
multivariate analysis using JAMOVI?
Sorry, madam.
Can we do multivariate analysis?
We are going to do it one-way ANOVA, two-way ANOVA analysis. We are going to do that. And as we have so many other aspects, we'll cover it up to only one-way, two-way ANOVA. Okay. Multivariate analysis, two-way ANOVA we are going to carry out. Okay. Not entire ANOVA family, but at least two tests we are going to conduct. As mentioned in the flyer, we are going to cover one-way, two-way, chi-square test. There are two types of chi-square test: goodness of fit test, independence of sample t-test. So, yeah. Okay.
Okay, sir. Thank you so much. Thank you all the participants. We are calling it a day. And tomorrow again at 7:30, we'll be meeting to continue our session. Thank you, everyone, and have a good day.
Thank you. Thank you, everyone. Thank you so much.
Thank you, sir.